So we said that triangle's got to add up to be 180. So subtract these two to get 76. These two are a linear pair. So we know that they're going to add up to be 180. These are vertical angles. So if that's 36, that's 36. These are vertical angles. So I had to recap for my virtual audience. And then what'd you get for this one, Lily? Got what? 79. Nice. So if that's 36, that's 65. Subtract those from 180, you get 79. Great job, Lily. Go ahead and hook you up with the Jolly Rancher. Here you go. Yes. I'm glad you caught that. That wasn't my best throw. How about 4, 5, and 6, guys? Angel, you want to help us out?
Before I got 45 by adding the 65 of angle 3 and then 70.
Oh, because how many degrees should be in this right here? Yeah, all three of these are linear pairs, guys. That all should add up to be 180. So if that's 65, that's 70.
And then,
so that's 45 degrees. I agree.
so find like the blank angle next to 118. Goes to subtract 118 from 118.
Yep, that's a linear pair.
You would add 62 and 45, and then subtract that line from 180, which gives you 76 and 85. And then for the bottom angle, like the blank angle, you would add 65 and 82, and then subtract that from 180, which gives you 33, and then subtract that from 180, which gives you 147.
Oh my goodness, she's a machine. So if that's 33, these are a linear pair, aren't they, Angel? So you said that would mean angle 6 has to be. Nice work. Between you and Lily, you guys absolutely demolished this thing. And Jacob, does it seem like there's a lot of repetition here? What do you notice we did a lot of times? 3 times, actually. 4 times. Yeah, we subtracted from 180, didn't we? To find a lot of, once we got 2 angles in a triangle, we just kept subtracting by 180. We did that 4 times. So, and we used linear pairs a lot too. We used linear pair here, linear pair here, linear pair here and here. We used vertical angles here and here, here and here. I mean, look at all the skills we were busting out there, guys. That's fantastic. Fantastic stuff. Any questions you guys have on that one? Because that's one of the most complicated problems we've honestly done. So I kind of like it though. It's like a puzzle.
How do you subtract the 7?
Number 4?
Yeah.
So do you see how we have this straight line right here, Cody? Would you agree that all of that would be 180 degrees? So that includes these 3 angles, doesn't it? So we could say, okay, this angle plus this angle plus this angle all should add up to be all 180 degrees. So if that's 65, that's 70, then we know that has to be whatever's left to make the 180. So we did a 180 minus 70 minus 65, and that'll tell us that piece. Yep, good question. Any others before I let somebody help us set up number 2 for a Jolly Rancher? Okay. Number 2 is a lot simpler. If you see what to do, it's a lot shorter too. It's a heck of a lot shorter. Anybody maybe for a Ranger want to help us set up number 2 here? This involves the property on the previous page that we introduced yesterday. Really? I'm surprised there are no takers for this one. Christian, what kind of angle do we see on the outside here? What do we call an angle that's outside of the shape? I can't hear you, man. Oh, okay. I thought maybe you would watch that yesterday. I got you. Jacob, I think I heard you say it. Exterior, yeah, it's an angle on the outside. And Isabella, do we have two angles on the inside? In fact, what are those angles? If they're not beside the exterior angle, they are. Yeah, they are, but there's a word before that interior. Something interior angles. Remote, who said it? Is that, oh, yeah. I like that look. Duh, it was me. And what do we know about remote interior angles? What do they add up to be? They don't add up to be 180. That's a good guess. I saw a lot of people doing that yesterday. They were trying to add these two up to 180. That's not true. To add up to 180, you need this angle too. They don't add up to 90. No. Go back to the previous page, Cody. What are we told here? The measure of an exterior angle is equal to, I think it was you that even read it, the sum of the measures of the two remote interior angles. So in other words, guys, your exterior angle is made up of the two interior angles added together. Well, they gave us the two remote interior angles. So 80 plus, I like Cody, you were just kind of throwing out popular angles. I like that. So we can add up these two, and we know it's going to add up to be. Yep. This was interior. This was interior. And it adds up to be your exterior. And I'm going to let you guys see if you can work that out for me. Take some time, guys. Combine like terms. We're gonna solve for x. Then you're going to plug x back in to find our two missing angles. What's up, Coach? Yeah, so you'll find out what each of those are. Yep. And I'm going to go to you here, Cody, if that's okay. Sure. Yeah, if this were me, obviously combine the 86. I would move that 6x over. That way I'm not having to worry about dividing by a negative number. So I'm going to subtract that 6x. That would be kind of how I would do it. But again, there's multiple ways to solve an equation like this, guys. You could have brought the 15x over. You just would have had to have divided by a negative 9 at the end. Speaking of 9, Cody, what'd you end up getting when you worked this out for x? X equals 9. Yeah, that's convenient. Check it out. You subtract 5 over, divide by 9, x equals 9. And so is the problem done? No, what do you got to do, Cody? Yep, you got to take 9, plug it back in for x on both those. And when you did that, Cody, what'd you get for our exterior angle? I got 140 degrees. For that whole angle? How about for this bottom interior angle? 60? I agree. Nice work, man. Nice work. Let me hook you up here. What are some questions you guys maybe have on this one? I know that's kind of a new property. That's probably why a lot of us didn't remember it. We were like, oh, wait, I forgot that that's even possible. That these two remote interior angles add up to the exterior angle. That's one that's kind of tough to remember sometimes, if I'm being honest. All right. So if you can believe it, guys, we just have really two problems left. That is all you have here. But what I want you guys to do, I'm going to give you the next couple minutes. I want you to look over this problem at the bottom of the page, and I want to really give you guys some time to look over this one. Really take some time, and I'm going to give you a hint. We're going to use the exact same property we used in this problem just now. Eventually, we're going to need to do remote interior plus remote interior adds up to be the exterior. That property is going to be how we set up our equation, just like on the last one. But I'm going to give you guys a chance to see if you can find out how we set that up. There's a little bit of work we have to do to kind of get things in place. But I'm going to go ahead and give you guys a couple minutes. Look over this one and see if you can set up our equation. It's going to look kind of like the last one. Dummy. Only a little bit of a dummy. Big thing here. If you find out this first step, this problem becomes 1,000 times easier. Jacob, what do you notice, man?
angles the same as the inside?
Oh, because what kind of angles are they? They're vertical angles. Yep, they are congruent because that angle and that angle are vertical. And so, wait a minute. Now, how many angles do we know inside this triangle? We know 2. And do they just so happen to be the 2 remote interior angles compared to that? Yeah, this is our exterior angle. This angle and this angle are not beside this angle. What does that mean they do then if they're 2 remote interior angles? Yep, if they're the 2 remote interior, then when we add them up, they're going to add up to be the exterior angle. So here was angle 1, remote angle 2, gives you the exterior angle. And I'm going to let you guys who haven't had a chance go ahead and finish that problem out. And if you have had a chance, you can go ahead and be getting a head start looking at the last problem of the day, which is on page 3. Hey, I can already hear the groans of excitement. But for my people who are still working through this one, take your time, guys. Don't want to rush you. And Jacob, by the way, what'd you end up getting for X on that problem? 7. That is correct. Again, I always like to combine my X's to where it's not going to be negative. So add 8 over, gives you 21 equals 3X. Nice work, Jacob. Here you go, sir. Very nice. Yeah, Jack just found it. Let's go. Anybody still need that, guys? I don't want to rush. We still got plenty of time, so I'm not trying to rush. We only got one problem left before I turn you guys loose on a little bit of homework. All right. Hey, I love it. This looks kind of familiar to what we've been doing. We got a triangle. Ooh, what kind of angles, Chandler, what kind of angles do you notice we have on the outside of this triangle? Ooh, I'm thinking we're probably going to have to bust out that exterior angle theorem. That lets us add up the 2 remote interior angles. I'm thinking that's probably going to come into play if we got some exterior angles. But in the meantime, I'm going to let you guys see what we remember, because almost all of this is old material when it comes to proofs. I'm going to give you guys a second to look over this. And go ahead and fill in the information they gave us. Look at what they gave us here. Jack, what are the 2 angles that they gave us? So that's 101, and that is 84. Okay, so we are given those. We're good to actually fill that in. And what do you guys notice is the very first statement here? Do we got math, or do we just got some words? Justin, is that just a straight up statement? If it's just a straight up statement, well, that's a definition of what? Absolutely, guys. If we're just saying, hey, 1 and 2 are a linear pair, that's a straight up definition of a linear pair. And I don't know if you remember what follows, but after the definition of a linear pair always follows. Not quite the definition of supplementary. That comes whenever we say that after something supplementary, that means it adds up to be 180. That's going to come here in a second. There's another linear pair thing that we always have after the definition. Postulate, yeah. Guys, these 2 are connected at birth. Linear, pair, postulate. They are always connected. And speaking of always connected, this next one is almost always connected to those 2. And you guys already said it. Angel, what did you say? We got words to math about supplementary being added up to 180. And Angel is absolutely right. That's the definition of sup. Those 3 are connected as can be.
So I had it right, this is in the wrong order.
Yeah. You were 1 step early. Usually we always say definition when it comes to sup after we have said words to math, that because it's sup, they add up to 180. that's when we can bring in that definition of sub, because that's what it means. Remember, we're thinking conclusion. What is the conclusion of that definition? Whatever it is, that's where it goes. The conclusion of supplementary definition is it adds up to be 180. Ooh, how about this next one? It looks almost identical to step 4, but we changed one thing. Jake, what are you thinking we did with that angle 1? It was angle 1 plus angle 2. Now it's...
Still the same angle.
But we did something. We replaced it. So, Jake, what do we call that? It sounds like a snake, the start of it when you say it. I can't hear you. Did he just say it? Yeah, there we go. Substitution. Sorry, I was being goofy. And so, guys, if we know angle 1's 101, let's substitute that in. And then clearly, Lily, how did we end up getting angle 2 here? We took 101 and we subtracted it over. Yeah, we used some subtraction. Here's the part that's a little tricky. Where are we getting angle 5 equals angle 2 plus angle 3? Let's look at that up here. Let's look at that up here, guys. So angle 5, okay, that's an exterior angle, is equal to angle 2 plus angle 3. Oh, shoot. What kind of angles are those based off 5? They're remote interior. That's what we're going to go back to. What we learned to start the day, guys. Yep. The 2 remote interior angles add up to be the exterior. That's what we're going to bring in the new. That's the only new part of this whole proof. The exterior angle theorem. And from there, I think honestly, go ahead. Any questions on that one? Because I think honestly, you guys can take this the rest of the way. It's the last 2. Question, Jacob?
I don't know.
So we just said that if you have an exterior angle, we know that these 2 remote interior angles are going to add up to be equal to it. That's based off that theorem we learned to start day 2. And so then from there, guys, I think most of us have probably got it. What did we do with 2 and 3? Hunter, say it again. We substituted. We replaced angle 3 with what it equals and angle 2 with what it equals. And then I think you guys can see what we did for the last step. Combine those 2 together using CLT. If you put addition there, you wouldn't be wrong. I would still count that if you put addition. So, hey, it feels good, a little proof throwback. Really, the only new thing we had in there was the exterior angle theorem. Seems like a lot of you guys kind of remembered probably 80% of that. If you only remembered 50%, that's awesome. But what I'm going to have you guys do, our homework is going to be numbers 1 and 2 on the bottom of this page. And then we're going to have a Google form, guys, over the practice multiple choice on the back page. There's just 4 of them. So your homework is going to be 1 and 2 on the bottom of this page, little algebra 1 throwback. So homework, bottom of page 3 and all of page 4. Yep. Just these 4 practice multiple choice problems and those 2 system of equation problems. All right. Thank you very much.